Thank you for joining us today. As it's in the very title, I will try to give an answer to the question, what is all the fuss about SPSS? I will first start with a brief overview of statistical data analysis by asking what, why, and how, then move on to descriptive statistics, and then follow with the inferential statistics, including relationships and comparisons, and we will finish with a Q&A. So what is data analysis? In practice, I know it's a nightmare for most of us. In theory, it's the process of collecting and organizing data, and then analyzing data to discover underlying patterns and trends, summarize data from a sample, explore relationships, and make comparisons. In reality, however, it's a hobby and even fun, at least for me it is. And questionnaires, surveys, and tests are commonly used instruments to collect data in educational research. There is a very effective online platform called Quadrix to create, distribute, and view questionnaire, survey, and/or test results. It is also available at the University of Glasgow under IT services, software, and online tools. You can log into Quadrix by using your guide and password. In addition, IT training team offers introductory courses about how to navigate the platform, design and format different types of questions, and use the features of data analysis. Again, you can book a course under My Glasgow IT services, IT training. SPSS stands for the Statistical Package for the Social Sciences, which is one of the most widely used software packages in social sciences, marketing, healthcare, and government. All file formats that are used for structured data can be opened. For example, Microsoft Office files, plain text files, or Stata and SAS. There are useful features in the data menu to save time and effort. You can sort cases with respect to gender, grade level, marital status, so on and so forth. Or you can split the file to repeat the analysis for groups, for instance, smokers and non-smokers. Or you can select cases to generate a subset of your sample. You may wish to include only smokers to analyze. And there are many more. You can assess normality, check outliers, and conduct missing data analysis. SPSS is used for computing two main statistics. One of them is the descriptive statistics to summarize and organize the characteristics of a data set. For example, gender, age, socioeconomic status. You can compute the frequencies, percentages, means, or you can characterize your distribution by computing the skewness and kurtosis and crosstabs. The other one is the inferential statistics. It is to test hypotheses, assess the generalizability of data, and draw conclusions about populations based on samples. Inferential statistics includes performing comparison tests, correlation, regression, as well as reliability analysis, non-parametric tests, and factor analysis. How SPSS is performed? I tried to summarize it in 5 steps. For sure, the first step is the download process, and students and staff can request SPSS for Windows and Mac through the Glasgow University help desk. You can follow the instructions to install SPSS on your machines. However, make sure that you need to fill out the software request form in order to start the process. Alternatively, students can use the Glassgo Anywhere Student Desktop to access SPSS. You can launch the SPSS via your web browser. Step 2, designing a study. Here's a sample of variables and a codebook. Assume that you collected data from 2 different grade levels. Grade 7 coded as 1, grade 8 coded as 2, and you collected gender data and coded females as 1 and males as 2. Assume also that you collected data to measure test anxiety with a test anxiety scale including 30 items, and participants responded that scale on a 4-point Likert scale from 1 almost never to 4 almost always. Similarly, you collected data to measure metacognition with a metacognitive awareness inventory including 17 items on a 5-point Likert scale from 1 never to 5 always. And finally, you collected data to measure mathematics achievement with a mathematics achievement test including 18 multiple choice items, and you coded incorrect answers as 0 and correct answers as 1. I will talk according to these variables with respect to the descriptive statistics and the inferential statistics. Step 3, entering data. Here is the variable view, which is displayed in SPSS. It's a more detailed explanation on the exact meaning of the study variables, which I mentioned in the previous slide. So it serves as a codebook. On the other hand, data view displays data values. The first record here, for instance, it contains a grade 7 female student who responded as some of the time to the first item, almost never to the second item of the test anxiety scale, and so on. Sorry. Step 4, you need to recode the items which are negatively worded. So you need to reverse negatively worded items to produce consistent values with positively worded items. Suppose that you have a mathematics teaching efficacy beliefs instrument on a 5-point Likert scale from 1 strongly disagree to 5 strongly agree. An example of a positive item, item 12, the teacher is generally responsible for the achievement of students in mathematics. And an example of a negative item is item 21. I do not know what to do to turn students onto mathematics. So by using the old and new values, you can transform recode into different variables of that negatively worded item 21. 1 recorded as 5, 5 recorded as 1, 2 recorded as 4, 4 recorded as 2. However, the neutral items in the middle of the scale will be coded as they are, 3 recorded as 3. Next stage, calculating the total scores. You need to add together scores from all the items or questions that make up the subscale, subdimension, or scale, test, inventory, questionnaire, whichever instrument you use and whichever analysis you would run through. SPSS provides this option under the transform compute variable to get the total scores of your study variables. And the last step is describing the data. There's a favorite saying of mine: above all else, show the data. And SPSS provides graphs under the chart builder option. Histograms display the distribution of a single continuous variable. For instance, you have total scores on test anxiety, total scores on metacognition or achievement, or other continuous variables such as age, weight, height, or temperature. On the other hand, bar graphs display the score on a continuous variable. For instance, metacognition across a categorical variable like gender only, or as is the example here, gender and grade level together. This bar graph displays that although females had higher metacognition scores than males, the difference in scores is very small across grade levels. Or you can also conclude that females are more metacognitively aware than males, and this difference is slightly more pronounced in lower grade levels, such as grade 7. And SPSS chart builder also shows you with the colors. For instance, here females are colored in blue, whereas the males are colored in red. So you can make the comparisons straightforwardly. Line graphs display the comparison of changes in the mean scores of a continuous variable. Again, let us take metacognition across different values of a categorical variable or variables like gender and grade level. Line graphs are excellent idea before exploring comparisons, and they are useful for delving into the details of the results of analysis of variance. Scatter plots display the relationship between two continuous variables, for example, test anxiety and metacognition. They are excellent idea before exploring correlations, and a scatter plot not only provides information about the whole sample, but also presents additional information of scores on test anxiety and metacognition across gender. Here, the points form a line starting high on the left-hand side and moving lower on the right. This indicates a negative correlation between test anxiety and metacognition. This implies that as test anxiety increases, metacognition decreases, or vice versa. And as you see, the points are scattered all over the place in a blob type arrangement, showing that this relationship is weak in the whole sample and across females and males. Here, I would like to note that graphs are not enough. Whether or not relationships, differences reach a statistical significance can be determined only by running inferential statistics such as regression or ANOVA. We will talk in the following slides. So let the data analysis begin. SPSS can compute frequencies and percentages in terms of the descriptive statistics under the analyze option. And the output viewer actually holds nice tables with all statistics on all variables we chose. And from this table, for instance, let us take first the gender table here. You can conclude that there are 501 females which constitute 53.1%, and 442 males, which constitute the 46.9% in the sample, giving a total of 943 participants. Similarly, you can talk on the grade table. There are 477 seventh graders, which constitute the 50.6%, and 466 eighth graders, which constitute 49.4% in the sample, again giving a total of 943 participants. Descriptives tell the same fairy tale, but with continuous variables. Here, SPSS provides you with the mean, standard deviation, minimum and maximum scores, as well as the characterization of the distribution by providing the kurtosis and skewness. And they live statistically ever after. Your continuous variables can live statistically ever after when you are able to talk on the minimum and maximum scores or values, or the means and standard deviations. Let us take the metacognition as a continuous variable here. The participants lowest scores on metacognition is 27, whereas the maximum metacognition score is 90. The mean score of the metacognition scores in the whole sample is 63.14, whereas the standard deviation is 11.182. Let's gather together the frequencies and descriptives under cross-tabs. SPSS provides you with a cross-tabulation here. For instance, the cross-tabulation of grade level and gender. From that table, you can conclude that there are 252 females, which is 52.8%, and 225 males, which is 47.2% of the participants attending to grade 7. You can also make this particular conclusion with regards to the grade 8 as well. Now, let's move on to the inferential statistics. Let us talk on the relationships in Wonderland. So here, you are burning with curiosity in the Wonderland about test anxiety, mathematics achievement, and middle school students. And suppose that your overarching question is, what is the relationship between middle school students' test anxiety and mathematics achievement? And we get in trouble with SPSS because of our curiosity in asking the research question, is there a statistically significant relationship between middle school students' test anxiety and mathematics achievement? We get in more trouble with SPSS because of our curiosity in testing the hypothesis. Null hypothesis states that there is no statistically significant relationship between middle school students' test anxiety and mathematics achievement. And alternative hypothesis states that there is a statistically significant relationship between middle school students' test anxiety and mathematics achievement. So our job here is to conclude whether or not we fail to reject the null hypothesis. So you can perform under analyze and the correlation option SPSS, And here is the output that SPSS provides us with the Pearson correlation coefficient. From that table, you can conclude that results revealed that there was a statistically significant and negative correlation between middle school students' test anxiety and mathematics achievement, because the Pearson correlation coefficient R is negative 0.12. And this implied that highly test anxious students tend to perform low in mathematics compared to their counterparts with low test anxiety. However, the strength of this relation was small according to Cohen's criteria. You can talk about the magnitude of your relationship by using Cohen's criteria, changing from 0.10 small to 1 large. And you may want to cook the comparisons. Comparison chefs in the means kitchen needs independent samples t-test here. The question is that, is there a statistically significant difference in the mean metacognition scores for females and males? When you run the independent samples t-test, SPSS provides you with the conclusion that results show that there was a statistically significant difference in metacognition scores for females and males. The reason is that the significance value is under 0.05, and you are here provided with the T statistics. You may wish to compare the, you may wish to cook your ingredients from a single set of participants, patients, machines, or match pairs, or different occasions, or under different conditions. Paired samples t-test are used to perform such sort of data analysis in terms of the pre-test, post-test experimental designs. An example of a research question is there a statistically significant change in middle school students' mathematics achievement after participating in an intervention to increase metacognitive awareness? In other words, you are asking the question, what is the impact, effect, influence, or effect of this metacognitive intervention on middle school students' mathematics achievement? You may also have ingredients like one categorical coded or continuous recorded independent variable with 3 or more categories, such as low, medium, and high, and one continuous dependent variable, such as test anxiety, metacognition, and mathematics achievement. You can pick up one of them, and this requires performing one-way analysis of variance. Again, under the analyze option of SPSS, you need to compare means and click on the one-way ANOVA. Your dependent variable will be mathematics achievement here. And if you pick up test anxiety to investigate the comparisons, you need to take test anxiety recorded from 1, 2, and 3 in the factor box. And the research question will be, is there a statistically significant difference in mathematics achievement among middle school students with low, medium, and high test anxiety? So here, SPSS provides you with the ANOVA table. since overall significance value is 0.003, which is less than 0.05, there is a statistically significant difference somewhere among the low, medium, and high test action students with the F statistics provided in the table. However, multiple comparisons tell exactly where the differences in the mathematics achievement among the test anxiety groups occur. You can talk on the descriptives along with the post-hoc test, including these multiple comparisons. For instance, from this table, you can conclude that the mean mathematics achievement score for low test anxious students with a mean of 11.05 and a standard deviation of 4.24 was significantly different from the medium test anxious students with a mean of 10.10 and a standard deviation of 4.22, and high test anxious students as well with a mean score of 9.46 and a mean and standard deviation of 4.22. Notably here, as can be seen, medium test anxious students, which are recorded as 2, did not differ significantly from high test anxious students because the significance value is greater than 0.05 in terms of mathematics achievement, which is 0.20. And let's recall line graphs. It will be a deja vu. I hope you recall the line graphs that I mentioned in terms of the descriptive statistics. Here, if you click on the mean plot option in the SPSS, it will provide you the line graph of this comparison. It shows you the differences in mathematics achievement scores among the test anxious students. This is the similar one with the descriptive statistics option with regards to the line graphs. Last but not least, SPSS also provides you with the analysis of exploratory factor analysis if you are interested in developing or adapting questionnaires, inventories, and scales, and you want to reduce the factors, you can use the exploratory factor analysis, multiple regression, logistic regression, two-way analysis of variance, multivariate analysis of variance, and analysis of covariance. And if you are interested in learning more, I would strongly suggest this 5 textbooks, and one of the most useful as a cornerstone is the Judy Pallant's book, SPSS Survival Manual. It's a step-by-step guide to data analysis using the IBM SPSS software, along with the interpretations and along with the research questions. It's a really useful textbook that you can utilize. Also, if you are interested more in multivariate statistics, advanced data analysis techniques, you can also take a look at the using multivariate statistics of Tabachnik and Fidel. Thank you.